हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका स्वागत करता हूं केमिस्ट्री वाला चैनल पे रिगार्डिंग टू केमिस्ट्री। इन प्रीवियस वीडियो वी हैव डिस्कस्ड अ लॉट ऑफ थिंग रिगार्डिंग टू दिस हैलोल्केन एंड हेलोरीन. Now I would like to go with the stereochemical aspects as our ninth point. The point is very important, that is optical isomerism. Optical isomerism. If we'll go with this isomerism, then what is the meaning of optical isomerism? So first is you can say two or more compounds having same molecular formula, but their mirror images are not superimposable, not superimposable, called as optical isomers, and phenomenon is called as optical isomerism. Optical isomerism means particular molecular formula same हो और उनकी मिरर इमेज एक दूसरे पर सुपर इम्पोज ना हो. द मीनिंग ऑफ not superimposable is chirality. If we'll go with the just conditions for the optical isomerism, then for optical isomerism there should not any kind of element of symmetry. What is the mean of element of symmetry? You can say center of symmetry. Just you can say plane of symmetry, and you can say axis of symmetry. मीन्स किसी भी टाइप की कोई भी सिमेट्री प्रेजेंट नहीं होनी चाहिए. खास बात व्हाट इज दैट? देयर शुड प्रेजेंस ऑफ ऑप्टिकल एक्टिविटी, मीन्स पर्टिकुलर कंपाउंड सॉल्यूशन स्टेट में प्लेन पोलराइज लाइट को रोटेट भी करना चाहिए. They should just you can say asymmetric, you can say chirality also. There should chirality of the molecule. These are the essential conditions for the optical isomerism. If we'll go with the just optical isomerism, then we have discussed it will be two optical isomers. One of the is your D form on the basis of optical activity. This is the optical activity, should have symmetry, and this is the optical activity. On the basis of optical activity, one of them will be D form, while another will as a L form. D form is also called as dextro-rotatory form, or you can say plus form also. If you will go with the another form, then that is called as levorotatory form, or you can say minus form. This is the minus form by using bracket. If we'll go with the just D form and L form, then D form rotates rotates to the plane polarized light, plane polarized light in clockwise direction, clockwise direction, and L form L form rotates to the plane polarized light, plane polarized light in anti-clockwise direction, in anti-clockwise direction, which we have discussed along with the optical activity deeply also. This was about the just D and L form. If we go with the example of optical isomer, then we can take as example one. This is the 2-chloro butane. Regarding to it, this is the 4 carbon in chain. This is the Cl. On balancing here will H 2 3. This carbon number 2 follows the all the conditions. So if we'll go with the structure, then as a structure we can take like this. This is the C. You can take C, C and C. This is the CS3. This is the C2S5. This is your Cl. This is your H. Here is your mirror. Here is the mirror. And this is the C. This is the CS3. This is the C2S5. This is the Cl and this is the H. Now to distinguish the about D and L form. So as a DL and L form, we can take the rotation. So high priority group is your Cl, after then C2S5, after then CS3. It looks like just your clockwise. But remember one thing, here is the H. सीक्वेंशियल होना चाहिए आपके पास में Cl के बाद में C2S5, C2S5 के बाद में CS3. अगर सीक्वेंशियल नहीं है तो जो फॉर्म आपको दिख रही है उसका जस्ट अपोजिट यूज करना है. So this is the clockwise. So this should be D form, but it will be L form as a optical isomer, and this will be your as a D form. And you can see both are mirror images of each other, but they are not superimposable. This was about the optical isomerism. Now the time to discuss about the 10th topic, that is your enantiomers or enantiomerism. What is the meaning of enantiomers and enantiomerism? This was 9th topic. Now we'll go with the 10th topic, that is your enantiomers, enantiomers, and you can say enantiomerism. If you will go with the meaning of enantiomers or enantiomerism, then you can say just two or more from two or more from which are mirror images, which are this is the which are mirror images of each other, called as enantiomers. And this property This property is called as enantiomerism. Enantiomerism. What is the basic difference between enantiomerism? Enantiomers exist same physical and chemical properties except except रोटेशन. केवल और केवल पेन पोलराइज राइट का रोटेशन डिफरेंट होगा, एक एक क्लॉकवाइज डायरेक्शन एक एंटी क्लॉकवाइज डायरेक्शन रोटेट करेगा, बट उनकी फिजिकल एंड केमिकल प्रॉपर्टीज सेम होती है. दिस वाज अबाउट द एनेंटियोमर्स. नाउ द टाइम टू डिस्कस अबाउट द डायास्टीरियो isomers. This is the most important property. Diastereoisomers. What is the basic thing? Just you can say when two or more form of a compound are not mirror images, then just are not mirror images of one another, then they are known as diastereoisomers. Diastereoisomers. What is the major thing? These edges, what? Just different physical and chemical properties. मीन्स जहां इनेंशियोमर की फिजिकल और केमिकल प्रॉपर्टी सेम थी, यहां इनके लिए फिजिकल और केमिकल प्रॉपर्टीज डिफरेंट होगी. हाउ? लिसन मी केयरफुली. There is a lot of important thing. I'll go with a lot of example to explain the just enantiomers and diastereoisomers. Just if there is two chiral center, just compounds having two chiral center. वन chiral center के रिगार्डिंग तो बात कर चुके हैं. टू chiral center जिनमें एक ही था, 2-chlorobutane, butane 2-ol. There is a lot of example, and if you want to go with the just example of the one chiral center, then you can take over here. First of all, compounds having one chiral center. So this is the first is your 2-chlorobutane. This is the second, butane 2-ol. This is the third. You can take 2-amino propanoic acid. 2-amino propanoic acid. You can take the example of glyceraldehyde. If you will go with the structure of 2-chlorobutane, then this is the structure CH3, this is the CH, this is the Cl, and CH2 CH3. You can see this is the chiral carbon. It's a compound with the one chiral center. If you will go with the butane 2-ol, CH3CH, CH2 and CH3, this is the butane 2-ol having one chiral center. 2-amino propanoic acid. This is the CH3. This is the CH, NH2, COOH. This exists one of the chiral center. If you will go with the glyceraldehyde, then this is the structure CHO, this is the CHOH, this is the CH2OH, is the chiral carbon. You can take the fifth example also, that is very important. It's called as lactic acid. Lactic acid. So regarding to lactic acid, you can take this. You can take the structure. It also exists in milk also. We have discussed in previous. This is the structure of lactic acid, just chiral carbon. So this was about the just organic compounds, or just you can say organic compounds with the one chiral center, or compounds with the one chiral center. Now we'll go with the just compounds with the two chiral center also. See the matter. So now the time to discuss about the just compounds with the two chiral center. It's very important because of you will got a lot of. So now the time to discuss about the just compounds with two chiral. So this is the compounds with two chiral centers. Chiral centers. If we'll go with the just compounds with the two chiral center, we can take a lot of compound. One of the is your tartaric acid. Tartaric acid. Another you can take 2,3 dibromo dibromobutane. You can take the example of third butane 2,3 diol also. These are the very important compound regarding to the just compounds having two chiral center. If we'll go with these, then these are very important. How we can calculate the total isomers of the compound also. So this is the time to discuss about the structure. If we'll go with the tartaric acid, then this is the tartaric acid. Just structure will be as follows. This is your COOH. This is the CHOH, CHOH, and this is your COOH. Here are the just two chiral center. This one is your 1 and this one is your 2. If we want to calculate just a total isomer for this compound, total isomer, I am not asking just total optical isomer, I am saying just total isomer, then the formula is 2 is power n, where n is equals to number of just chiral center or chiral carbon. If we go with this compound, then it exists 2 chiral carbon, so total isomer will be 2 is power 2, it will be 4 isomer. 4 isomer. If we'll go with the structure, then first two isomer will be as follows. This is the COOH, you can take over here. COOH, this is the COOH. Here is the just OH and OH. Here is your H and H. These are the chiral center. If we'll go with the mirror image, then mirror image will be as follows. COOH. This is the COOH. This is the H. This is the OH, and this is the OH. Mirror image, it will be as follows. This is the mirror. This is the mirror. So this is the first form. This is the second form. Now I would like to go with the just here are the two compound. Now the third and fourth compound will be as follows. These are the COOH. This is the COOH. Here are one of the OH, H. This is the H and this is the OH. These are the chiral center. On taking mirror over here, then this is the mirror. So the mirror image will be as follows: COOH, COOH. This is the H, this is OH, this is the OH, and this is the H. And the chiral centers are these 1 and 1, 2. This is the compound number third, and this is the fourth. If we go with the just important thing, what is that? If I go with this compound, then here is the one of the plane. When I pass this, then it will formation of the two equal part of the compound. कंपाउंड के दो इक्वल पार्ट का फॉर्मेशन होगा और ये वाला पार्ट इस पर, ये वाला पार्ट इस पर सुपर इम्पोज है. दैट्स व्हाई दिस काइंड ऑफ द प्लेन इज कॉल्ड एज प्लेन ऑफ सिमेट्री. और हमने आपसे बताया कि मॉलिक्यूल में किसी भी टाइप का सिमेट्रिक एलिमेंट नहीं होना चाहिए. तो पर्टिकुलर प्लेन ऑफ सिमेट्री के कारण से इसका एक हेल्म का रोटेशन जस्ट OH, COH एंड H, इसके दूसरे हेल्म का रोटेशन एंटी क्लॉकवाइज एंड क्लॉकवाइज दोनों एक दूसरे के रोटेशन को कैंसिल कर देंगे कुछ इस टाइप से. इस फैक्टर को, जो कि एक ही मॉलिक्यूल में काम कर रहा है, इस फैक्टर को हम कहते हैं इंटरनल कंपनसेशन. दिस फैक्टर इज कॉल्ड एज इंटरनल कंपनसेशन. इंटरनल कंपनसेशन. इसके कारण से पर्टिकुलर ये दोनों के दोनों ऑप्टिकली इनएक्टिव होंगे. फर्स्ट एंड सेकंड फॉर्म, these are the optically inactive. Those compound which exist just asymmetrical carbon atom like this, but due to presence of plane of symmetry they are not optically active. Those form of the compound are known as mesoform. So we will call these two structure as a two form of the mesotartaric acid, and you will say mesoform will be optically inactive due to internal compensation. दोनों हेल्म का रोटेशन एक दूसरे को कैंसिल कर देगा, रिजल्टेंट ऑप्टिकली इनएक्टिव होगा. रिगार्डिंग टू दिस, if I pass the plane of symmetry like this, then there will not formation of the two equal helm जो कि एक दूसरे पर सुपर इम्पोज हो सके. इन दैट केस पर्टिकुलर बात करूं तो यहां रोटेशन के रिगार्डिंग तो आपके पास में पर्टिकुलर ये वाली फॉर्म होगी डी फॉर्म, और ये वाली फॉर्म की बात करूं मैं पर्टिकुलर आपके पास में तो ये वाली होगी आपके पास में एल फॉर्म. एल फॉर्म मीन्स दोनों की दोनों आपके पास में ऑप्टिकली एक्टिव होगी. These will not as a mesoform. These will be D and L form. So what we can say that total isomer 4 में से आपके पास में 4 isomers में से regarding to two chiral center, 4 isomers में से आपके पास में it will be 2 of mesoform, 2 of will be as a mesoform, and 2 of will be as a optically active form as a D and L form. This was about the just important thing. One thing is also important जो कि आपको एक्सप्लेन करना है. जस्ट फर्स्ट फॉर्म एंड सेकंड फॉर्म, थर्ड एंड फोर्थ फॉर्म, ये एक दूसरे की मिरर इमेजेस हैं. सो दीज आर नोन एज एनेंशियोमर्स. These are known as enantiomers. And if I go with the form number first and third, and you can say second and fourth. These are not mirror images, not mirror images, so they exist different physical and chemical properties. That's why these forms are known as diastereoisomers. So this was the basic difference, dia, stereo, isomers. This was regarding to just two chiral center. One thing is also important, whenever just same group along with the just chiral carbon are in same direction, then those are known as erythroform. This is the important word for the NEET and IIT. Erythroform. Erythroform. जब आपके पास में सेम ग्रुप कायल कार्बन चटे सेम डायरेक्शन में हो, and if both are in opposite direction, then those are known as trioform. Trioform. Remember one thing, erythro and trioform. Erythro, this is the erythro, and trioform. Trioform are basically used for the sugars to know the configuration. And this was about the just entire part of the your diastereoisomers, enantiomers, and this compound with the two chiral center. Regarding to these compound, आपको इनका प्रैक्टिस करना है और वही फोर स्ट्रक्चर फॉर्मेशन होंगे और उनके रिगार्डिंग आपको मीजोफॉर्म और enantiomers बना के देखने हैं, diastereoisomers और enantiomers. So this was about the just entire part of the today. We'll meet in the next video. Till then शुक्रिया, धन्यवाद. वीडियोस को, चैनल को शेयर करना, सब्सक्राइब करना ना भूलें ताकि उन बच्चों तक की पहुंच भी पहुंच सके जो अभी हमसे दूर है. तब तक के लिए शुक्रिया, धन्यवाद.